On some nights, when the sky over a powerful thunderstorm is clear, you might see elves, gnomes, trolls, or blue jets. Blue jets sound kinda random here, right? But we're not actually talking about fairy tales. These are all just different types of lightning flashes that are mostly visible very high above raging thunderstorm clouds. Let's take red sprites. Those are flashes of light that appear above thunderstorms that come in clusters. They are rare because they're only caused by a specific type of lightning called positive cloud-to-ground strikes. So a positive charge is transferred from a thundercloud to the ground during a lightning strike. These types of lightning make up only 10% of all lightning strikes. For more than half a century, many believed these flashes were just urban legends. People did see them from time to time, but the flashes were so brief that even if you had been lucky enough to catch them, you wouldn't have had time to call someone to witness this phenomenon with you. Even when respectable scientists or pilots would talk about them, the scientific community would mostly ignore them. In 1989, something strange happened. The researchers from the University of Minnesota actually managed to catch sprites on film, and that's how it started. People across the world began sharing videos and photos of red sprites. Red sprites can start as 328-foot balls made of ionized air. These balls shoot down from heights of about 50 miles at 10% of the speed of light. And researchers have been studying not only the lightning that plunges down from raging clouds, but these colorful flashes that go towards space too. So, electricity stretches up to the electrically charged ionosphere, but at the same time, it crushes down towards the ground. Red sprites come in different shapes, like these big, cool jellyfish sprites that sometimes have areas that measure up to 30 square miles. You may see carrot sprites or column sprites. They're similar, it's just that carrots also have long tendrils. The lower parts of tendrils are often blue, while the higher ones are red. On August 22, 2022, we were able to take some stunning photos of red-white streaks in the sky above the Atacama Desert in Chile. They were surrounded by another bigger glow of greenish color. It's something we call air glow, and you can only see it this well when there's no light pollution. It's basically when we use too much artificial light, and among other things, it doesn't allow us to observe stars and other objects we might otherwise see in the sky. And this airglow happens because of atoms of nitrogen and oxygen in our atmosphere. Sunlight knocks away their electrons during daytime. Then, they slowly recombine with their electrons, which is a process that causes them to glow. How can you see a red sprite? First, you need to find a large thunderstorm. They're more common during summer and spring, for example in June. Of course, sprites can appear at any time if there are powerful enough storms with lightning at ground level. The skies need to be clear and very dark, ideally without bright moonlight. And the storm should be around 100 to 200 miles away. That way, clouds won't block the sky and you'll have better visibility. In the perfect scenario, the storm will be moving along a distant horizon, so you'll be able to see everything above the cloud tops. You can track a storm with weather radar. Your eyes need some time to adapt to the darkness around you. Give them some time, about 20 to 30 minutes. Keep your eyes above the clouds and try not to look at the clouds directly. Ignore lightning flashes. A sprite will pop maybe once for every 200 lightning strikes. Don't expect to really capture it on camera, it's not easy. But the view itself will likely be worth the wait. This and similar flashy events are something we call TLEs, which stands for Transient Luminous Events. Blue jets are also worth mentioning. These are dim blue lights that stream up like a very fast puff of smoke above powerful hailstorms. They're also very rare, and in most cases, you'll only be able to see them from an airplane. And now we get to those fairy tale creatures. Elves, when we talk about lightning flashes, are brief disks of dim light you can see about 60 miles high in the atmosphere. It's just an abbreviation. Their full name is emissions of light and very low-frequency perturbations due to electromagnetic pulse sources. Yeah, I suggest we stick to elves. Moving to trolls. Those are red spots that pop close to cloud tops after the flash of a very powerful red sprite. Gnomes are the smallest and fastest flashes. We're talking about tiny white spikes of light that flash from the top of a big anvil of thunderclouds. The anvil is that elongated cloud you see at the top of a raging storm. It spreads downwind together with upper-level winds, and gnomes last for only a microsecond. And check this out. Ball lightning is in the shape of fiery orbs that can be as big as a golf ball or can grow up to a very large beach ball. They can be yellow, red, white, orange, green, or purple, and they can stay alive for a couple of seconds, even minutes sometimes. Over the centuries, many people have been talking about how they saw ball lightning, sometimes even floating into their homes. But such events are really unpredictable and happen very rarely. Scientists have managed to recreate ball lightning in the lab, or at least something very similar to it. They have realized that ball lightning probably shows up after a lightning bolt strikes the ground. Mineral grains in the soil then vaporize. Here's something spectacular: volcanic lightning. This one is born in the plumes of a wild volcanic eruption. Like the rest of thunderstorms, volcanic lightning forms when static electricity builds up in Earth's atmosphere. And then it gets released in the shape of a lightning bolt. Scientists don't understand the whole mechanism here, but they think it's related to charging. For example, ice charging is what causes thunderstorms to form. It plays a part in producing lightning during volcanic eruptions too. This happens when the air heated in an eruption rises into the sky and meets cold air. The water from the eruption turns into ice particles, and when these particles bump into each other, some electrons get knocked off. The ice particles that now have more positive charges move higher into the sky and gather together. Or it may be frictional charging, another thing that leads to volcanic lightning. The same as ice charging happens when tiny particles of ice collide. Here we have ash and pieces of rock colliding and creating charged ions. There's dark lightning too. Over 10 years ago, researchers discovered that thunderstorms could generate brief but very strong bursts of gamma rays, which is the form of light with the highest energy. They are so bright that they can blind sensors on satellites, even when they're hundreds of miles away. They can also create antimatter. Antimatter is a type of matter made of particles with opposite charges compared to the particles in normal matter. Imagine having two boxes full of blocks. Some blocks are red and some are blue. When these pairs touch each other, they disappear or annihilate and turn into energy. That's what happens when particles of matter and antimatter meet. And these flashes could be the result of dark lightning because it gives off light that's not really visible. Regular lightning involves slow electrons. In dark lightning, electrons are high energy. They crash into air molecules and, by doing that, produce gamma rays.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.